Please welcome our panel, Solving Edge Cases, The Path to Accelerating AI, with Chris Barker from CBC Transportation Consulting, Jack Xiaojiang Guo from Nuro, and Kai Wang from Zoox.
Hello, welcome to our Solving Edge Cases, The Path to Accelerating Artificial Intelligence. My name is Chris Barker. I'm the CEO for CBC Transportation Consulting. And today I have the pleasure of being joined by Jack Guo, who is head of Autonomy platform at Nuro, and Kai Wang, director of predictions at Zoox. Welcome, Jack. Welcome, Kai.
Thank you, Chris.
So today we're talking about edge cases and the impact they have on autonomous mobility and in the advancement of artificial intelligence, and specifically looking at edge cases being kind of viewed as uncommon driving scenarios, things that perhaps are unique to a particular driving scenario or situation. For example, something like a autonomous vehicle traveling down a roadway and seeing a stop sign inside a traffic cone, or some unexpected object in the road. These edge cases create all sorts of unique opportunities and challenges. And I would like to get your collective opinion on, as you look at edge cases, how do you approach these edge case scenarios when you're designing your autonomous drive systems? And what impact do they have on your planning activities within your respective organizations? And Jack, I'll start with you. Welcome your thoughts on that.
Sure. So I think in order to understand how we approach the edge case scenario, first we need to understand why the edge case scenario is important. As we build out the self-driving car technology, we're constantly pushing the boundary of our technology, and edge case is basically the scenario that lies on the boundary. So it's super important for us to have a really good way to discover those scenarios, to know where our boundaries are, so that we can iterate very effectively and effectively pushing that boundary. So that's basically our high-level approach, where we have a bunch of feedback mechanism to discover the edge cases and then design solutions to target solving those edge cases. As we iterate, as we improve, we over time, have better and better self-driving car capabilities.
And Kai, from your vantage point, how are you and your team approaching edge cases in your development process as well?
Yeah, so to piggyback on what Jack is saying, especially when we're driving in dense urban environments, if your goal is to drive tens of thousands, hundreds of thousands of miles, edge cases, might be something that happens once every 100 miles, but then that accumulates and that kind of shows up actually fairly often. So optimizing that whole life cycle of being able to discover something new, but then go back to the data and being able to find it in our data, and then enable the developers to kind of come up with ideas and then optimize and to try to come up with things that'll solve it, is really kind of building that machine to address these, because edge cases, it's kind of unpredictable, when they'll show up, and I think they always will show up. I don't think any of us predicted that we'd be all at home these past couple of years, or the emergence of parklets in cities now, all these new things. So just being structured in a way that you can respond quickly is really important for us.
And how much time would you both say you spend on identifying edge cases and then figuring out the path to resolution on those edge cases as it pertains to the autonomous mobility operations? Can you give a sense of what that looks like? Jack?
Sure, I can start. So basically there's the short answer is a lot. So basically we want to make sure we progress, constantly pushing the boundary performance on those edge cases, but also making sure we don't regress on the non-edge cases. So yeah, as you can imagine, so these are the two overarching objectives, and we spend a lot of time on those edge cases, discovering, solving, testing, and validation.
Kai, thoughts?
Yeah, it's kind of baked into our regular testing cycles. We're we drive, multiple thousands of miles every week. And through that, with the interaction of like our safety drivers, and, kind of what we observe in the field like that, like we're really kind of trying to structure it in a way that these edge cases just emerge and kind of go into this machine where, we have some humans, observe what's going on, help kind of tag it, but then, kind of feed it back naturally to the engineering team. So yeah, I think, we try to be structured to handle edge cases as much as possible.
And that process, Kai, you were just describing, so you tag an edge case. Can you talk about how you go about identifying other edge cases in this huge volume of data that you're parsing through? So you can start looking at different commonalities or other ways to approach perhaps other edge cases. Can you describe that process a little bit?
Yeah. So, like there's only so much that one will observe through driving. There's always kind of this infinite set of things that you might have never seen, but, for human drivers, they're like phenomenally well handling edge cases or things that they've never seen. So, we look to the data that we get from our driving as inspiration for situations, which then, you can take that as a seed and, as part of a broader validation process, construct, similarly hard things, but like, using, being rooted in what we see from the field. So it's not enough just to solve everything you see, but you really want to use that and kind of be creative to think about what else is kind of the similar nature to those things that you've seen to kind of have the best coverage you can.
And you touched on something there where you mentioned humans and how humans can overcome edge cases fairly quickly based on a body of experience. Can you both of you talk a little bit about where does the human interface play into this edge case analysis process and making decisions and analyzing the data and then determining best next steps going forward? Where is the machine learning and where is the human interface? How do those two parts come together? Jack, do you have a thought on that?
Yeah, so we rely on human to provide some like basically ground truth in this discovery process. Like just for example, as Kai described, like we have safety drivers drive a car on the road, and whenever they discover something that's unusual, they will disengage, right? Like, and such decision is made by human, and later look at by our in-house team, a dedicated in-house team, to root cause these disengages to say, hey, what's the root cause of this? Is it perception issues? Is it this specific model, or is this like prediction, or is it planning issue? So that give us some really good feedback mechanism to surface those edge cases.
Okay. And I want thinking about a recent example. So we just had the Halloween holiday. You have an event where people are dressing up in costume, walking down sidewalks, with other pedestrians. Now we introduce autonomous vehicles, and now the vehicle has to determine somebody who perhaps doesn't look quite like they normally would. Talk about an awesome edge case. How do you attack something like that and try to figure out how to provide logic and reason in the system when you're looking at people of different sizes dressed in costume, perhaps at night? There's obviously a lot of complexity associated with that type of situation. How might each of you approach a scenario like that?
Yeah, I'll jump in first. You're right that humans, are remarkably good at handling things, a wide range of things, especially things that we've never seen. And like we're never going to see everything in our data. We're never going to have training data for every possible thing. There's always going to be a new costume or a new situation.
Right.
One thing that we focus on at Zoox is, leveraging multiple modalities as much as we can. So, for example, like the nice thing about LiDAR is that, it's a direct measurement of like if there's like an obstacle in the way. So at the very least, even if we can't classify what this obstacle is, if we don't know it's like a person in a dinosaur costume, we know it is an obstacle with a sufficient number of points and sufficient level of confidence from that modality that we will not end up colliding with them at least, and kind of use that as like a trigger to like either call for human intervention to help or something like that. So I think multiple modalities and kind of having layers of behavior and mitigation is pretty important as our AI gets better and better over time.
Hey, Jack, go ahead.
Yeah, just to piggyback on Kai, we basically make sure we design a robust solution because what the self-driving car technology we put on road, self-driving car, it has to be safety first. So aside from the robust in sensor, robust in the operational mitigation, but also we can try to design the solution to be as generalized as possible. You can imagine, if all the development or fixes are for these edge cases are just band-aid fixes as they come up, the solution doesn't generalize, and there's an unlimited amount of edge cases that you will encounter. So by focusing more on a general solution, either from the modeling perspective or from the overall robotic system design perspective, is really important to.
And Kai, to your point, you've got radar, LiDAR, GPS elements that are all built into the vehicles. How do these different layers of technology help in that identification of perhaps someone in a Halloween costume or something that doesn't look quite like it normally would? How is that giving you added resource to help in the identification of these objects in the path of vehicles or in the proximity of vehicles?
Yeah, absolutely. Each sensor modality has their strengths and weaknesses. LiDAR is a great modality to tell us if there's a thing there. Radar also is a really effective modality that's a little bit less impacted by some environmental factors. It gives you a little bit more semantics from each return, but it also has some drawbacks in today's radar. But to give it, when it works, it kind of gives you a little bit more information than LiDAR does. And then vision really you get the really rich kind of ability to get semantic information. It's the highest resolution. You get kind of can infer the most from that. So sensors like LiDAR and radar are really good for redundancy, really good for not just running into obstacles. Vision is really great for some higher level understanding of what people are doing, if they're gesturing, if some subtle thing.
Yeah, just to add, so the human in costume is probably edge case for the camera, but not the case for LiDAR. So by having multiple sensor modality, we can basically make sure we have added robustness there. So even if camera fails, LiDAR still be able to reliably detect that's an obstacle, and we will not hit the pedestrian with costume.
And then how does that sensor information feed in and advance the artificial intelligence and the machine learning so that you can start doing this at scale? Perhaps broader geographic areas, more similar type incidents. Can you describe how one helps serve the other?
Yeah, I'll offer my 2 cents on that. The key challenge is how do you leverage how do you benefit from the kind of the good things about all these modalities, and then fuse them together, fuse the results together, so that you can reason about these discrete entities downstream in prediction and planning. So that is kind of fundamental to the perception problem, perception tracking, and we spend a lot of engineering time trying to solve that, and yeah, it's really about kind of getting the best out of each one of these things, but then combining the results together in kind of a data-driven way to get a single final result.
And how are you sharing edge cases across your organizations, perhaps with the cities where your vehicles are going to operate ultimately? Can you describe a little bit about the information sharing, the data sharing that's taking place so that ultimately the vehicles that are deployed are being done safely, effectively, efficiently? Any insights on how your analysis can then parlay into the real world deployments?
Sure, maybe I can start. So before we deploy on any city or any region, we basically collect a bunch of data. and feed those and label some of the data, especially the hard cases, and then feed them into the model so that model can generalize that city. Also, from the modeling design, you want to design this in a way that's as generalizable as possible, so that a pedestrian in Houston it can be detected by only pedestrian data collected from Mountain View.
And Kai, your thoughts on that?
Yeah, no, I think those all made sense from what Jack said. Yeah, each city has its own kind of distribution of the different, both like entity types, but also behaviors, and yeah, the more we can, and we definitely want to try to leverage, things, data collected, situations that we encounter in one city to another. And sometimes we explicitly go to certain parts of the city that we know to be to have a certain number of edge cases or certain frequency of certain edge cases. Like we try to test in, say, the densest part of San Francisco to actively try to find these things, so that when we expand to other places, it should hypothetically be an easier time because we've exposed ourselves to more examples of this sooner.
I use that Halloween costume example, but what other really challenging edge cases are you coming up against that you find particularly challenging, time-consuming, that you're using a lot of your resource to try to figure out how do we deal with these? Any other examples that come to mind?
So maybe I can jump in first. Maybe a lot of like pedestrians and cyclists where their behavior and intention is not like super well defined, right? Like a pedestrian can choose to cross the road or can choose to go along sidewalk, or sometimes like can choose to jaywalk. Like especially in cases where there's a lot of occlusion, right? Like basically pedestrian sudden review, and those type of situation are like more related to safety critical, and we focus a lot of our attention on that.
Yeah, and I think like edge cases come in different forms. Like on the perception side, things like rubble on the ground, or like various forms of debris where you have to distinguish: is this a type of debris that I'm willing to drive over? Is this a plastic bag, or is it something kind of something like that? Or is it something that I don't want to drive over? Is this a bowling ball, or is this like a pile of bricks? Or there's kind of an infinite space of these things. So I think that's that's a challenging problem. In addition, like trucks with a lot of or vehicles with a lot of like protrusions out of them, those kind of remain challenging edge cases on the perception side. And then for prediction, behavioral edge cases, and multi-point turns in like dense traffic and just like really like tight road configurations. Things like that, U-turns in a junction. Yeah, once you start looking at behaviors, there's a wide range of these things that are possible.
I'm glad you bring it up, Kai, because I'm thinking about the classic 3-point turn, and not all 3-point turns are equal. How do you take and try to come up with something that's down the middle or as standardized as possible, and in a situation that has a lot of variables to it?
Yeah, I think for that, it really comes down to your validation plan, and it starts with what you see in your data, but that's kind of just like the initial seed. You really try to leverage other things as well. You try to leverage our track testing, structured testing, where you can stage some of these situations, and especially simulation, where you can really start to get a huge variety of these situations that you wouldn't encounter if you were just driving alone. So it's multiple paths to this.
Yeah, sometimes not only with real world data, but also synthetic data, like in the simulation, to uncover and solve some of the edge cases, especially behavior edge cases.
Yeah, simulation is so important. Time for one other question. So as you think about moving forward, what is needed to better address edge cases collectively as an industry? What tools, resources, methodology, some of the above, all the above is needed to tackle this perhaps at bigger scale?
Maybe I can start. So I think we need to have a tooling and process, which includes, simulation or, everything included, to quickly iterate on the edge cases. So whenever you discover edge case, you incorporate that into this big black box machine, big machine, to drive the performance of self-driving system, and then deploy that on the road. So just making that cycle to iterate really fast is crucial for the improvement of the self-driving car stack.
That's a great point. Kai?
Yeah, I think in addition to that, it's just really important to build like kind of a cohesive safety validation plan that takes these into account. And I think everyone in this industry is kind of constructing their own version of what this their whole safety argument is for this. And edge cases is kind of like a one part of this. So understanding things like the frequency, the exposure to these things, to be able to categorize them well enough that it fits into this overarching validation plan and kind of safety portfolio is really critical, and will kind of help inform when you're kind of done or done enough that like you feel safe and confident enough to drive. Otherwise, this is like kind of you can work on this forever. There's kind of an infinite number of things, and new things will always show up.
Absolutely. These are great points. Jack and Kai, thank you both for taking the time to chat this afternoon. Look forward to continuing the conversation offline, and appreciate your time, and look forward to keeping in touch. Thank you.
Thank you, Chris.
Thank you.